Hello, these are the solutions to the final three problems from our review packet. So the last problem from this page here is a chemist adds 0.15 moles of lithium chloride to a 250 milliliter volumetric flask, fills to the mark with water, assuming that all the solid dissolves. We then pipette 4 mils of that solution into then a 50 milliliter volumetric flask and want to know the concentration of lithium chloride in the final 50 milliliter flask. And so let's do the first flask first. So our concentration lithium chloride in, let's call that the first flask, would be 0.15 moles, and we're dividing that by a 0.250 liter flask because that was our total volume of solution. So that is going to be 0.60 molar lithium chloride. And then if we take 4 milliliters of this solution here, so I do 0.004 liters because that's 4 milliliters times that concentration. That's how many moles of lithium chloride I've transferred to the new flask, and the new flask is 0.050 liters. So our lithium chloride solution in our solution 2 would be 0.04 times 0.6 divided by 0.05, or 0.004, sorry, times 0.6 divided by 0.05, it's 0.048. Now for this step here, I was really just using the concept of molarity as moles over volume. You could also have done M1V1 equals M2V2, so an approach could have been taking 4 milliliters times 0.60 molar to use like MIVI equals MFVF. And so this is our MI and VI equals MF as our unknown times VF of 50 milliliters, and we get to the same answer. Moving on to the final page. Right, and balance the reaction between aluminum metal and nitric acid. So they do react together. So aluminum plus HNO3. We'll go to AlNO3. 3 is our salt, water soluble, plus H2 gas is the byproduct. I wouldn't worry a whole lot about this reaction here other than we have the 0 going to 3 plus, that's aluminum being oxidized, and the H plus to H0 being reduced. To balance this, we're going to do, let's do a 2 here, a 2 here, a 6 here, and a 3 here. And so let's imagine also that we give you the reaction. So we'd probably be likely to give the reaction if we want to ask this problem on a test. But then how much aluminum metal, so how much, HNO3 in liters is needed to fully dissolve 27 grams of aluminum? Well, let's just do this with dimensional analysis. 27 grams of aluminum, that's approximately the molar mass of aluminum. For every 2 moles of aluminum, we need to add 6 moles of HNO3. And the concentration we have here is 0.50 moles of HNO3 per liter of that solution. So that looks like 3 divided by half, that's going to be 6 liters. It's going to take 6 liters of that acid solution. Then our final question. Consider the metathesis reaction between silver nitrate and calcium chloride. We have a mole of each reacting. What are the molarities of all the ions present in the solution once the reaction is complete? So the reaction taking place is AgNO3, AQ, plus CaCl2, AQ going to AgCl. That's our insoluble salt driving the reaction, and then calcium nitrate. and this is an AQ for the calcium nitrate. And so I don't know if this helps to think of the ionic reaction, but this is water soluble, that's water soluble. This is not water soluble, this is water soluble. So calcium and nitrate are the spectator ions. They're the things that are present in ionic form on both sides of the equation. And then silver and chloride are the ions being dissociated. Now we have 1 mole of each of these is what 1 liter times 1 molar gives us. And so I think we can see that if we consume all the calcium chloride, we would need 2 moles of silver nitrate, but we don't have 2 moles of silver nitrate. So the silver nitrate here becomes the limiting reactant. And so for every 2 moles of silver nitrate, we need to react half of the calcium chloride. And so half of the calcium chloride reacts, leaving the other half of it behind. And so all of my silver nitrate reacts, half of the calcium chloride reacts, but all the nitrate and all of the calcium remain in solution anyways, and then only the silver ion goes to 0. So the silver ion goes to 0, so I have 1 mole of nitrate ion. So my concentration of nitrate is unchanged here, so I had 1 mole of it initially present, that's the same concentration finally present, 2 liters of solution, that's half molar. Calcium ion is also not changing, so I have 1 mole of calcium initially present, and I have 2 liters of solution. And then I have precipitated half of my chloride, and I have half of a mole of calcium chloride remaining. Well, there's 2 chlorides per mole, so that's 1 mole of chloride. So I have 1 mole of chloride remaining, 2 liters of solution, it's half molar as well. So all these other ions are at half molar. So the 2 types of problems to expect on the test for stoichiometry are ion concentration problems like the final question here, or just basic stoichiometry problems like the one above.